So it's your turn now, and you show us how to clean with what methods you would propose to clean biofilms in whatever. Okay? Thank you very much.
Thank you, Hans. Good morning, ladies and gentlemen. So thank you for giving us the opportunity to present our technology based on enzymes. So the title is Biofilm Treatment for Improved Food Preservation. So I will explain now with this content how we can act on biofilm. So first I will explain what's biofilm. I will after explain how to use enzymes to improve food preservation, and I will finish with some case studies in order to show you and to demonstrate what are the gains for the food industry. So first, biofilm, as explained before, can be present everywhere. You can have biofilm on teeth, on bottle, but also for sure in pipes and the different techniques you are using in food industries. So for us, biofilm is composed of two things. First, you have microorganisms, and you have a protective layer made on organics. It's what we call the EPS for exopolysaccharides. So it's two things, and for sure, enzymes will be focused on this EPS structure in order to give access to the microorganism. When you have a biofilm inside a plant, inside a unit, it's very dangerous because you can have some unpredictable release of living microorganisms that can contaminate the finished product. You have to avoid that for sure. In the food industry, you have different concern issues when you are facing a biofilm contamination. So we can talk about product contamination for sure, and it's very dangerous because it can lead to economical losses. You have to recall the products that are contaminated and are present on the market. And also it's dangerous for the companies because you have strategic risk, because you can have loss of public confidence. So you have to avoid biofilm to be present in your plant. When you have some biofilm, you have some microorganisms on the finished product. This can have a bad impact on the shelf life of the product. I will explain that a lot later also. When you have biofilm, you can have some reduction of the productivity. For example, in a membrane filter, it reduces the flow that is passing through the membranes. But also you can have some reduction of the performance. For example, in the heat exchanger, if you have a biofilm, it's not good for the energy transfer. Also, you can have some bacterial resistance, because the microorganisms are able to act on the biocide, on the sanitizer, because they can destruct those sanitizers. We are also talking about biofilm biocorrosion, because you can, the biofilm can act on the stainless steel and destruct the stainless steel. Those are many reasons to act on the biofilm and try to get rid of this potential contamination. So these are the three steps for biofilm growth. First, you have the biofilm adhesion. It means that the microorganism can attach on the surface and be present on the plant. After that, you have the biofilm grow, and you have this production of the organic matrix made on organics. And the final step is the step 3, where you have the mature biofilm that is able to release some planktonic microorganism, but also part of the biofilm, including microorganisms and EPS structure to go anywhere else in the plant. So these are the main 3 steps that we are facing for the biofilm grow. And for sure, our objective is to limit biofilm not to go on that last step where the biofilm is mature and can release some living microorganisms. These are the common strains that you are facing when you are acting on biofilm. So those first one, Listeria, Bacillus, Salmonella, Pseudomonas, are well known in the food industry. And we know that Pseudomonas is very present in the water process, and for sure Bacillus cereus in the dairy industry. So these are the main strains that you are facing and identifying when you are proceeding some biofilm treatment. It's very important to act on biofilm and evacuate this biofilm from your plant, because biofilm is a kind of sponge that can trap some other elements like allergens, like DNA from, for example, in the horse DNA, some companies were facing some big concern about that. We also have some phages that can be retained in the biofilm, and when the biofilm is reading some part of the biofilm, you can have some phages in the finished product, so it's not good for the production quality. So now I will explain how enzymes can act on the biofilm and why enzymes are different than standard chemicals. So you have a picture, and those pictures are coming from the INRA, National Institute in France, because we made a 2-year study with them in order to find the right way, the right enzymatic cocktail in order to act on the biofilm and be sure that we are totally destructing the biofilm structure. So you have the initial biofilm structure before standard chemicals and after enzymatic-based product. So first, you have a layer. The biofilm is composed of the red spots are the bacteria, and the wires of different colors are the proteins, the EPS structure that is able to protect the biofilm. When you are cleaning with standard chemicals, you just have the standard chemicals are just able to act on the upper layer of the biofilm. You cannot act deeply into the structure, and the goal of the enzymes is to totally destruct this organic structure in order to give access to the microorganism. So it means that when you let circulate the cleaning solution, thanks to standard chemicals, you will just be able to extract and dissolve the upper layer of the biofilm. But if you are acting with specific enzymes in order to have a specific hydrolysis of this organic structure, you will dissolve the whole biofilm structure. And the red spots there are the initial microorganisms that are attached on the surface. But when you will evacuate the cleaning solution here, you will have access to the microorganism. It means that the biocide, the sanitizer, will be able to kill those microorganisms. If you are using standard solution, you are just reducing the biofilm contamination, sure, but you don't have any access, you don't have any access to those microorganisms who are still protected under the organic layer. So if you are using standard chemicals, little by little, you will increase the contamination of the biofilm and you will enter in a potential area where you can have some contamination. The goal of enzymes in that application is when you are facing some biofilm contamination, first you act with a curative treatment in order to get rid of all the microorganisms. And after that you follow, and you follow the quality of the production, and you need to find the right criteria saying that biofilm is present again. It can be the total amount of germs, it can be some specific pathogen, it can be the flow rate in a membrane filter. So you have to find the right parameter for you in order to assess the presence of the biofilm and for sure the potential contamination. It was very important for us also to help the industrial to locate and to find and to confirm the biofilm contamination. Because when you have some contamination in the finished product, it can come from different aspects of your production. So we developed 2 different techniques in order to assess the presence of biofilm. One for the closed system. So I will explain that later, and one for the open surface. Thanks to that identification, location, and quantification of the biofilm, we can disclose to the customer and help the customer to find the right procedure to get rid of biofilm contamination. In closed system, what we are doing, we ask the customer to clean with standard chemicals and right disinfection, a loop, for example. It can be one heat exchanger. And after that, we let circulate inside the heat exchanger one enzyme-based product solution. And we are taking some samples of the cleaning solution, And we are trying to demonstrate that we are able to extract some living microorganisms. So if after a normal procedure we are able, thanks to enzymes, to extract some living microorganisms, we are proving that we can go one step further than standard chemicals. So we put a sample of the cleaning solution in this specific growth media in order to assess the presence of microorganisms on it. We put that into incubation and we follow the turbidity that will grow inside the samples. So if after 3 days, for example, we have high turbidity inside the tube, it means that the customer is facing a strong contamination concern. We also can put those samples into UV light in order to reveal some fluorescent species like Pseudomonas fluorescens, for example. Also, what we can do on the samples we are taking is to make what we call what's called metagenomic. It's a PCR analysis in order to define the ratio and the different kind of germs you can have on the samples. It's very important to try to understand what kind of species of germs you have on the plant in order to try to find the origin of the biofilm contamination. Because biofilm contamination can be the air, can come from the water, the processed water that you are using, or maybe can come from the product themselves. We have to define in order to find the right solution where the microorganisms are coming. For open surface, what we do, we have developed one specific coloration that will be specifically linked to the EPS structure. It's very easy to handle. We spray to these two reactive, and after 15 minutes, we are able to say, okay, you are facing a biofilm contamination in that area, for example, or that area, or there. The blue is remaining because it's specifically attached to the EPS structure. It's also easy, for example, after a treatment to say, yes, you had biofilm before and now you don't have biofilm anymore. So now how can we improve, for sure, food preservation? It's very important to understand that in the food industry you have standard products, standard residue that are easily removed by standard chemicals, but you also have some persistent organic residue like modified proteins, like fat, like starch that are not easy to be easily removed by standard chemicals. But you also have the biofilm residue. So if you can act on all those parts of organic residue you can have on the surface, for example, you can have an effective cleaning and you can improve hygiene. In the shelf life topic, it's very important to understand that at each stage of the production, the surface can impact the quality of the finished product. Normally, the surface must be clean and without any microorganism on it. But it's very important to understand that if you are using, if the process is, you have remaining biofilm on the process, you will add some microorganism on the finished product. So, for sure, the shelf life of the product can be defined by the product itself, the production process, and also the packaging and storage condition. Thanks to biofilm treatment with enzymes, we will act for sure in the production process, and the goal is to reduce the contamination in the finished product. It means that if you are able to start at the end of the production with a lower contamination in the finished product, it will give you the opportunity to extend the shelf life. So we have some customers that ask us to extend the shelf life because they were facing some biofilm contamination, and this was dramatically impacting the shelf life of the product. And thanks to a more hygienic quality of the surface, we increase the shelf life. So now, in order to explain and to show you what enzymes can do in that application, these are some industrial cases that we performed during the last years. For example, this was a dairy yogurt industry, and this yogurt industry was facing some texture non-conformity. It means that at the end of the process, production process, the texture of the yogurt was not smooth. They had some granular inside. And they asked us to find and locate the biofilm. We were able to, thanks to the detection in closed system, we have been able to say that this heat exchanger was containing some contamination. So they just apply the treatment, and you can see here some samples we took during the full procedure. And when we put those samples into incubation, you can see here, this is the enzymatic treatment. We can see that we were able to extract some living microorganisms from the heat exchanger. And thanks to that, the quality was restored, and now they are not facing biofilm contamination anymore, and the yogurt is now smooth, as they want it to be. Another application is in beverage industry, and that company was facing some contamination issue, and after 15 days at room temperature, some flux were appearing in the bottles. It's just water, and they asked us to locate the biofilm, and once again we applied the biofilm detection in closed system, and we locate the biofilm in a filler and a mixing tank. And thanks to this application now, they are not facing anymore the concern, and they just have to apply 4 times a year a preventative treatment in order to avoid biofilm to be protected with the EPS structure. In membrane application, it's very important to understand that because you cannot apply high temperature, you cannot apply oxidating sanitizer, for example, in a reverse osmosis system, it's a good way for biofilm to grow because the conditions are very good. And that company was facing some contamination when they were using some specific membrane filters. And also, they were not able to restore the flow rate after a full cleaning session. We apply a biofilm treatment, and we also extract some parts of the filters. These are the spacer, and you can see the blue coloration specific from the open surface kit we have. And thanks to that, we locate the biofilm, and we also put the sample into UV light, and we prove the presence of Pseudomonas fluorescent. So thanks to that, the customer, before treatment, you see the flow rate, the water test flow rate after cleaning. You can see the flow rate has increased before and after the biofilm treatment, demonstrating that we were able to extract something from the membranes. The time is okay? Okay, so I have time. Very good. So one more example is butter industry. That company was facing some contamination in the finished product. And here you have the total amount of germs in the finished product, and you can see that above 800 contamination, they have to rework or destroy the product. It means that before the treatment, they had to destroy or rework some batch of production, and this was causing a lot of troubles for the company. We apply a biofilm treatment, and now, thanks to this biofilm treatment, and also the fact that they are running some preventative treatment, they are not facing high peaks of contamination anymore, higher than 800, which is the quality level, maximum quality level. You can also see that the average of contamination has been reduced by 2, and this was also a goal of the quality team from that company. So they are not facing some rejection of products anymore, and that's a good thing for them. Regarding shelf life of product, this is, sorry, not a dairy or beverage industry, but a shrimp company, a seafood industry. And that company asked us to locate the biofilm in their open system, but also in a closed system, because they are using cold water in order to after the cooking of the shrimps, and they are following the Listeria monocytogenes presence in open surface in order to define the presence of the biofilm. What you can see before our treatment, because we start the treatment there, the average contamination was 21, and thanks to that, they had a 6-day shelf life for the finished product. We apply the blue coloration, we run some biofilm treatment in the closed system, and thanks to that, now they can claim a 9-day shelf life for the finished product. It's 3 days more, 50% more. It's very important for that company because they could not reach that hygienic level before, thanks to standard chemicals. So this is the end of the presentation. I hope I gave you some relevant information for you in order to improve quality in food industry. And if you have any question, do not hesitate. One more information, we are present in the area A3, stand 1 to 3. If you need some more information, do not hesitate.
So thank you very much for this interesting presentation. I hope you have something, could get some information. Do you have any questions concerning that topic? Okay, back there. I will come to you. We have from eHedge some leaflets here. If you are interested in getting to know what eHedge is doing, you can get a yearbook, a leaflet, and some more information on our booth over there. I'm giving also advice to companies in that area. So if someone needs support in the area of hygienic design or mechanical hazards, then I can give some support on that area.
Eine Frage zur Kontaktzeit bei Reinigung, Desinfektion mit Enzymen. Time.
In that specific application of biofilm treatment, for the first application, we required 2 hours contact time. But in standard procedure, cleaning procedure, is not longer than standard chemicals. For example, in membrane cleaning, we are not exceeding the contact time of standard chemicals. It can be from 30 to 45 minutes, for example. There is no reason to increase the cleaning time thanks when you are using enzymes. No, there is no reason.
Thank you.
Are there any other questions? Okay, in the front. That keeps me young and tidy.
Thank you very much for your presentation. I just would like to know, do we need any change in our CIP system, existing one? Or is it possible just to add this enzymatic solution, let's say, into our chemicals or cleaning waters or flashing water? And the second question will be how you are ensuring that after this application, my system is clean and away from these enzymes. Can be also hazardful for my product. I'm sure there's also a way to do that. I was just wondering what it is.
First, for the first question about do you have to change anything from the CIP station you have right now, the only element that you have to change is the temperature, because we don't need 85 degrees to run enzyme-based product. 45 is the optimum temperature. You just have to reduce the temperature, but for the velocity, for the tanks, it's exactly the same. No changement about that. And concerning that very important question about inactivation of enzymes and validation that you don't have enzymes anymore in the last final rinsing water, for example, we have developed there are some techniques in order to quantify very precisely the presence of proteins on water system. Enzymes are proteins, so we can detect very precisely the presence or the non-presence of enzymes in the final rinsing water. This is for enzymes presence. And regarding enzymes inactivation, we can say that there is a switch on, switch off on enzymes. For example, if you increase temperature or if you use oxidating product or you increase the pH or reduce the pH, you will die. Enzymes will die. So we are able to inactivate enzymes totally in 100% sure that they are inactivated. We are using enzymes, and after that we are using some sanitation step, for example, and that will kill the yeah. Okay.
Are there any other questions linked to that topic? If you would like to have the presentations, I spoke to the two speakers here, and they gave me the information that if you give them your card, your business card, they would send you this presentation as a PDF file. So if you are interested in that, they offered that. I hope not thousands will come, but some they might be able to send. So be aware of that topic. I think it's very much linked to hygienic design. And if your facility is not hygienically designed, then you might not be able even to clean it. And that causes these kind of problems as well. And it makes it more serious. That's why start to rethink, is your facility really hygienically designed? And then you can also have a good result in that area. And I think we had two good presentations now. And if there are any further questions linked to one of these topics, we will be here for maybe 10 more minutes or 15 more minutes. You can come and ask us. And if you have any concerns or if you have any ideas, then come to us and discuss that face to face with us. Okay? Thank you for listening. Hope you had a nice time. And maybe we will see us sometimes again. We are free to come and get information to you, bring information. Okay? Bye-bye.